Bismillahirrahmanirrahim. I welcome you all in our today's online session. Hope you all are fine and having good health. We start today's session with the verses of Holy Quran. In the last session, we was discussed about sensitivity to disturbance, and we start today's lecture from this topic. As variation in ambient temperature, ambient is a particular kind of temperature which is related to the particular device on which it works in different kind of environments. Either a temperature is high or either a temperature is low, etc. Occurs certain characteristics, instruments characteristics change, and the sensitivity to the disturbance as a measure of magnitude of this change. So this disturbance from by the variation of temperature can emphasize on a certain instrument characteristics or also be changed and manipulate with the further measurement of sensitivity. Also, it changed the magnitude of the reading or values, you can say. So the effects of instrument can be emphasized in two ways, which is the zero drift bias and sensitivity drift. So two kinds of things can be happened. So sensitivity to disturbance can be fulfilled by this graph. You can say the nominal characteristics of fulfill can by this straight line of linearity, but the characteristics with zero drift can be fulfilled on this way, which is the undesired. So we coming towards zero drift. Zero drift is the reading of an instrument is modified by the change in ambient conditions. So zero drift is a reading of an instrument. Zero drift तब fulfill होता है रीडिंग में, और जब ambient temperature condition उसके मुताबिक modified हो रही हो, तब्दील हो रही हो. The mechanical form of bathroom scale is common example of an instrument that is run of bias. Zero drift is also found in voltmeters that are affected by ambient temperature change. Typical unit of its measurement is volts per centigrade. The drift is vary with the changing of voltage per degree rise of temperature, which is the coefficient of zero drift value. The characteristics of an instrument is sensitive to several environmental parameters. Then there are several zero drift coefficients, one for each environmental parameter. Further, the sensitivity drift, you can see amount by which an instrument's sensitivity of measurement varies with ambient condition changes. If the variation change of temperature can be vary, then the sensitivity measuring value by the sensitivity can also be vary. So quantified by sensitivity drift coefficients. So span drift in this figure, we can say the linearity of normal characteristics can be shown by here, but the span of drift, the variation in the reading of sensitivity can be looks like in this line, which is the straight away small variation of divergence from nominal characteristics of line towards the span drift in a straight line. So coming towards the zero drift, the nominal characteristics can be represented in the straight line. The characteristics with zero drift can be vary from the large deviation of distance it or looks like in this line. So quantified sensitivity drift coefficients can be varied with coefficient increasing. So in this characteristics of in this numerical, a spring balance is calibrated is an environment at temperature of 20 degrees centigrade and has the following deflection and load characteristics. The load in kgs and deflection in millimeter can represent by the 0 value. After that, the load can be increased per unit value of kg by increasing 1, 2, and 3 respectively. with respective of its reading related to the deflection, which is 20 millimeter, further 40 millimeter, and 60 millimeters. After it is often used in an environment at temperature of 30 degree centigrade at the following deflection load characteristics is measured after the temperature increasing at a degree of 30 degree. It would be the load can be increased similarly on the position of 0, 1, 2, and 3, but the deflection in millimeter on the starting of 0 load, it would be 5 millimeter, and after that in 1 kg same reading, the deflection value would be 27, and afterwards it would be 49 and then 71. With the increasing of the value and variation due to the increase in temperature, the drifting of voltage variation can be emphasized by the temperature variation with increasing size. Then the deflection can also be varied. So disturbance can be causes disturb the sensitivity, also increase the magnitude in the coefficients, which we discussed in our previous slide. Determine the zero drift and sensitivity drift per degrees change in ambient temperature. So coming toward the solution at 20 degrees centigrade, which is talking about this table, deflection per load characteristic is a straight line sensitivity, which is equal to the 20 millimeter per kg. And similarly, 30 degrees centigrade deflection per load characteristic is still a straight line sensitivity, that is 22 millimeter per kg. So the zero drift, it would be 5 millimeter, which can be happened here. The no load deflection, at the no load deflection, it would be 5 degree. Okay, sorry for the interruption. Further, we watched on the sensitivity, which is 2 millimeter per kg, can be observed. So after that, particular drift can be observed in this way that zero drift per centigrade would be 5 divided by 10. That particular variation that we have the value 0.5 millimeter per centigrade, and then the sensitivity drift per centigrade would be found by that two sensitivity value divided by the 10. that variation. So we can get the value of sensitivity drift per centigrade would be 0.2 millimeter per kilogram per centigrade. So that's how we can find the sensitivity drift from this way. So now further we coming towards the hysteresis effect in our measurement devices. The hysteresis effect, if the input measured quantity to the instrument is steadily increase, input value is steadily continuously अचानक बढ़ जाती है अगर increase from the negative value, कम हो जाती है, negative value means the in the magnitude of negative side वो बढ़ जाती है, the output reading varies in the manner shown in the following curve. The curve can be represented in this way. If the input variable is then steadily increase, the output varies in the manner shown in curve. So if the input variable is steadily decreasing in the negative side, the output varies in the manner of show in the particular curve. The non-coincidence between these loading and unloading curves is known as hysteresis effect. So that loading unloading, which means continuously increasing and decreasing in a particular hysteresis shape, then this known as the hysteresis effect. Most commonly found in instrument that contains springs. The spring, because it apply the force on a spring, it restored value, and after the removing that pressure from the spring, it storage of force can be restored from the spring, and this phenomena continuously happening by the restoring phenomena by applying on the pressure in the form of force. So continuously, it increase and decreasing value. It starts from this side of curve A, variable increasing, and then variable decreasing steadily when releasing that particular force. That particular force at this instant to this towards that maximum output at hysteresis can be observed. And after that, it is also be decreasing instantly and further can be restored into its original value, and this phenomena can be repeatedly continuously happening. So at this side, this of a curve value, maximum input hysteresis and the dead space. Dead space, now in the next slide, we can discuss that the dead space is defined as a range of different input values over which there is no change in output values. The different value variation in input can be happening, but there is no change in output. Any instrument that exhibits hysteresis also displays dead space. So if in most of these cases of hysteresis effect, the dead space is available in the hysteresis curve of graph. A range of different input values over which there is no change in output values. In an instrument that exhibits hysteresis also exhibits dead space. So most of the instrument which exists the hysteresis effect, then there is the fulfillment of dead space out there. However, an instrument without hysteresis can still have dead space. But some of the instrument have the effect of hysteresis, but still the dead space is out there. So this is another phenomena of dead space, which is the relevance of hysteresis, and another one is irrelevance of hysteresis with the dead space concept. So this is the dead space. The input value with the variation of output reading can be varies, but देर इज अ हिडन, यहाँ से वैल्यू गायब हो जाती है और इंस्ट्रूमेंट कोई वैल्यू शो नहीं करता, अवेलेबिलिटी नहीं रहती, तो उस दौरान पॉजिटिव या नेगेटिव साइड पे ही हम देख लें तो इस कमी को डेड स्पेस कहा जाता है, जिसमें इंस्ट्रूमेंट किसी खास इंस्टेंट पे आकर ना वैल्यू पॉजिटिव ना नेगेटिव देता है, बल्कि उस जगह वैल्यू मैग्नीट्यूड वाइज जीरो रहती है, लेकिन उस स्पैन ऑफ टाइम के बाद डेड स्पेस क्रॉस करने के बाद इंस्ट्रूमेंट की वैल्यू मौजूद होती है। So further, we continue our next lecture, which is lecture number 4, but in sequencing, this is lecture number 5, instrument calibration. So calibration is also an important aspect to maintain its sensitivity and to get the desired output by the instrument as per the user need. So we need the calibration. So the dynamic characteristics of instrument is also matter at the time. The static characteristics of measuring instruments are concerned only with the steady state reading, that is instrument settled down at a particular instant at which the settlement of value can be provided at that particular instant is the calibration requirement of the level. This is also the requirement of the user that a calibrated instrument can also be provide a good and perfect reading. That's the reason we need to get the value. The dynamic characteristic, which is the moving characteristics of the measuring instrument, describe its behavior between the time a measured quantity changes value and the time when the instrument output attains a steady value in response. अब इसके नतीजे में होता है कि जो डायनामिक कैरेक्टरिस्टिक्स होती हैं इंस्ट्रूमेंट की वैल्यू प्रोवाइड करती हैं और वो बिहेवियर ऑफ द इंस्ट्रूमेंट भी डिपेंड करती हैं। और ये जो बिहेवियर होता है ये इंस्ट्रूमेंट के साथ साथ टाइम वर्सेस मेजरिंग क्वांटिटी के दरमियान होता है, जो कि इंस्ट्रूमेंट आउटपुट के स्टेडी वैल्यू ऑफ रिस्पॉन्स के ऊपर डिपेंड करता है। फर्दर द इंस्ट्रूमेंट एंड मेजरिंग सिस्टम डू नॉट रिस्पॉन्ड टू द चेंज ऑफ इनपुट इंस्टेंटली। बाद इंस्ट्रूमेंट्स ऐसे होते हैं मेजरिंग के दौरान जिनकी मेजरमेंट हो रही होती है तो वो अपने इनपुट इंस्टेंटली यानी फौरन तब्दील नहीं करते। आउटपुट रिस्पॉन्सेज जो कि डिपेंड होते हैं उस पर टाइप ऑफ इनपुट कि आप कैसा इनपुट प्रोवाइड कर रहे हैं उसके मुताबिक आउटपुट होगा। टाइप ऑफ ट्रांसड्यूसर कौन सा इस्तेमाल कर रहे हैं जो कि सेंसिंग वो परफॉर्म कर रहा है, क्या आया उसकी रेंज भी है उसके लिए नहीं, या उसकी सेंसिटिविटी मोर ना हो कि उसकी रेंज ऑफ स्पेन में ही ना है, उसकी सेंसिंग में ना है और वो अपने खास रेंज में जाके ही रीडिंग प्रोवाइड करे। इनिशियल कंडीशन मैटर करती है कि वो इनिशियल कंडीशंस क्या है उसकी। सिस्टम कैरेक्टरिस्टिक्स ऑल्सो मैटर्स द आउटपुट के सिस्टम की जो कैरेक्टरिस्टिक्स है कि आया वो कैलिब्रेटेड है या नहीं, उसके सेट पॉइंट्स अवेलेबल है या नहीं, उसकी पावर सप्लाई अप टू द मार्क है या नहीं, और उसमें जीरो एरर तो नहीं है। तो दीज आर द रीजंस कैन आल्सो बी बेस्ड ऑन द आउटपुट रिस्पॉन्स ऑफ द टूल measuring device. So system can also be depends upon the following aspects which are related to the order of the systems. So order of system also matters. There are three kinds of system in which the concept of system can be exist, which are the zero order, first order, and second order. There are many of the orders which we call after second order to third order, fourth order, which are the higher orders. If we need to consider the kind of fifth order, then we have to divide it into different of parts, which is the second order, and first order. Then combining both things would be a fifth order. So this would be the one way to solve these kind of problems from to divide the system of understanding into different pieces of orders and combining both with each other with cascaded formation and to form a higher order. So one of the topic which are related to the first, second, or zero order are I explained in this link or website. I continue the session of order system by the next lecture. So up till now, hope you understand you all the kind of things. If you have any kind of question, query, or difficulty, you can feel free to ask on the comment section. I will answer the kind of question and resolve your queries regarding the INM lectures. So hope you understand these kind of concepts. Up till now, Allah Hafiz.